So here's Unit 1, Lesson 6, Solving Linear Systems by Using Substitution. So far we've learned about solving linear systems by graphing, using either technology or by drawing the graphs by hand. But as you may have come to realize, it's time-consuming, and sometimes it's difficult to graph and even to locate the point of intersection, especially if your numbers are not whole numbers. So how can we solve a linear system without graphing? Well, I'm going to introduce to you this method called substitution. I'm going to do this by looking at one of our previous examples. If you may remember an example from earlier videos, you play hockey and you get 2 points for a win and 1 point for a tie. Last season, your team had a total of 90 points. You had 4 times more wins than ties. How many games did you win? And so you may have remembered creating two equations for this. So let's create those two equations again. Now this time, I'm going to use different variables, just so that I can show you that you don't have to restrict yourself to just using x and y. So do we have to use x and y? No. Let's use, so let's say here, let's w be the number of wins, and we're going to use t for the number of ties. Okay, and so one of the equations will be, so let's say it's called this equation number 1, and equation number 1 will be, well, 2 points for every win, so 2 times the number of wins, w, plus 1 point for every tie, so every tie game we have is also equal to the number of points, will give us a total of 90 points. So we had a total of 90 points for the season. So equation number 1 is an equation based on points. Equation number 2 is an equation based on the number of wins. So we had 4 times more wins than ties. So the number of wins is equal to the number of ties, but 4 times the number of ties. So 4t equals w. Okay, so how do we use substitution? Well, substitution means I'm going to take one of my variables and replace it with the equation created from the same variable in the other equation. Okay, so let's use some reasoning here. So if the number of wins is 4 times the number of ties, then we can substitute this idea, this 4 times the number of ties, from our second equation for the w variable in the first equation. Okay, because at the point of intersection, these two equations have to be the same point. W and t have to be the same point. So I'm going to do that. So I'm going to let's write that down here. So if the number of wins is 4 times the number of ties, we can substitute, I'm going to underline substitute, 4 times t from equation number 2 for my w variable in equation number 1. Okay, so how does that look like? Well, let's write it down here. So let's write down equation number 1 again, but this time I'm going to replace my w with 4t. So 2 times w, but that's going to be replaced with 4 times t plus t equals 90. And by doing that, my equation now just has t as the variable. Okay, there's no more w, there's no 2 variables, there's 1 variable here. So let's simplify this a little bit. So 2 times 4t is 8t plus t equals 90. And then if I collect like terms, these are like terms, add their coefficients. So 8 plus the invisible 1 is 9. So 9t equals 90. And if I solve for t, divide both sides of the equation by 9. So 90 divided by 9. And so t is equal to 10. Okay, t is equal to 10. So the number of ties is equal to 10. All right, so how about the number of wins? Well, the next step would be to take your value of t that you just found and substitute it into either equation, okay? Because if you put t in this equation, you can find w, and if you put t in this equation, you can also solve for w. Now, it looks like equation 2 will be easier to work with, so we'll use equation 2, but you're going to get the same answer with either equation as long as you did this step correctly. So we're going to say here now substitute t equals 10 into either equation to determine w. Okay, so I'll use equation 2. So 2 looks easier because it's just one single step until you find w. So 4t equals w. If t equals 10, make that substitution. 4 times 10 equals w, and 4 times 10 is 40. So 40 equals w. I'll write it this way, where w equals 40. So the number of wins is 40. Okay, and so the point of intersection is 10 ties and 40 wins. Okay, and so that answers the question actually. How many games did you win? Well, we won 40 games. So therefore, we won 40 games. Okay, so we can use the substitution method to determine the point of intersection of two lines. And this is also known as finding the solution to a linear system. Okay, we use the substitution method when it is easy to isolate one of the variables. Okay, that's if it's easy to isolate, then substitution would be the perfect way of doing it. Okay, so let's look at example number 2. Solve for the following linear systems using substitution. So we have two equations here, 1 over 2x minus 5 and y equals negative 2. And I'm going to first, remember, this is what you have to choose the variable you're going to replace. Okay. Now, x is not ideal. You can, but you have to do a little bit of work before you can substitute x. What we can substitute is the y's, right? So y is by itself here, y is by itself here. I can just make the substitution. I can replace the y in this first equation. So let's call this one here equation 1, and this one here equation 2. The y in the first equation, I can substitute that with the y in the second equation. And the y in the second equation is negative 2x. So I can take the negative 2x and put it in here for y. So let's write that down. We are going to replace y in equation number 1 with the y in equation number 2, which is negative 2x. So let's do that. So equation number 1, here we're going to replace the y, negative 2x equals, on the right side I have 1/2 of x minus 5. Okay, now you see the equation has no y variable anymore, it's just an x, which means we can solve for it. Okay, so how do I solve for it? How do I get rid of the fraction? Well, one strategy you could use is to multiply both sides of my equation by 2. Right? 2 times this and 2 times that. Balance the equation by doing it on both sides. So if I do it on both sides, 2 times negative 2x is minus 4x. Okay, what happens when on the right side? Well, 2 times 1/2, well, it just cancels out the 2's, right? So on the bottom. So I just have an x. And don't forget distributing with the 5 as well. So 2 times 5 is minus 10. So x minus 10. Okay. Now, if I want to bring the x's over to one side, so I'm going to subtract x from both sides of the equation. So this cancels. And on the left side, I have minus 1x minus 4x, which makes minus 5x. And on the right side, I have my minus 10, or negative 10. And then if I divide both sides by negative 5 to keep the equation balanced, I'll have cancellation on the left, leaving me with just x. So x equals negative 10 over negative 5, which is positive 2. So there's my value for x. Okay, now I still need the value for y. So what you have to do is substitute this x value back into one of the equations. So let's say, so substitute x equals 2 in either equation 1 or equation 2. Which one looks easier? Well, it looks like if I use equation 2, I only have one step to find my y value. So we're going to say here this is easier. So taking equation 2, y equals negative 2 times my x value, which we found is 2, and that gives me a y value of negative 4. So there's my y value. I have my x value, so therefore the solution is positive 2 and negative 4. Okay. Now, it's easy to make a mistake. So you must always do this thing we call the checking step. So you're going to check our work, and you check your work by using both equation 1 and equation 2. So equation 1 says y equals 1/2 x minus 5. Check your solution satisfies both sides of the equation. So if y is negative 4, I put negative 4 in there. X is positive 2, I put 2 in there. I do my minus 5. So negative 4 is already simplified on the left. On the right side, I have half of 2, which is 1 minus 5, so 1 minus 5 is negative 4. So the left side equals the right side. LS and RS, left side and right side. So we've checked our work there. It looks good so far. We'll check our equation number 2. So equation number 2 is y equals negative 2x. So if y is negative 4 and x is positive 2, you just check, okay, negative 4 on the left, negative 2 times 2 is also negative 4 on the right. So left side equals right side, and we're done. Always do this step, because if you don't and you make a mistake, you can see the mistakes in this checking step. Because if the left side does not equal the right side, then you made a mistake somewhere along the way. In your substitution steps. Okay, so this is checking using algebra. Now, if you're doing your homework, you can also check using Desmos. So, check also with Desmos. But on a test, you may not have Desmos there. You have to use algebra. But if we did check using Desmos, what would that look like? Well, here I type in my equations. So I have y equals, so first equation is y equals half of x, so 0.5, x minus 5, and the other equation is y equals negative 2x. And here on the graph, I can see that they intersect at this point 2 and negative 4. So my solution is verified. Okay, let's have a look at another example. So x minus y equals negative 1, and 2x minus y equals 2. So here's the thing. The equations now don't have an isolated variable. Okay, I have to work now on isolating the variables. So let's say here, if one variable is not already isolated, you have to rearrange. So rearrange 1 or 2. Okay. So the question is, which one should I rearrange? Well, you should always pick the one, as much as possible, the one that doesn't have any coefficients, because that means you have one less step. You don't have to divide anything. And you pick a variable that's easy to isolate. Okay. So x is already positive on the left side. Why don't I isolate x in equation number 1? So we're going to call this equation number 1 and this one equation number 2. So if I use equation number 1, I can isolate x by adding y to both sides. So I'll have negative 1 on the right plus y. Okay, or you could say, well, moving the negative y to the other side, it's positive y. So now I have isolated my equation number 1. So that x is by itself, and I have my expression on the right side. So when you have that isolated variable, you can now replace it in the other equation. Okay, so we're going to say here, replace x in my second equation with -1 plus y. Okay, so let's write the second equation. So here's equation number 2. You're starting off with 2x, so 2 times x is going to be replaced with -1 plus y. And then I have a minus y in my equation, and then I have the equation equal to 2. Okay, now you can see we have an equation where there is a single variable, one unknown variable. We can solve for that. X is not here anymore. So follow your solving steps. So you have to kind of, don't forget you have to distribute here. So 2 times -1 is -2. 2 times y is plus 2y. Minus y equals 2. If I collect like terms, 2y minus y is just y. And if I add 2 to both sides, I can cancel this 2 on this one. And then I have 2 plus 2. And so y equals 4. So there's my y. Okay. Then everything else is just like the previous example. So the next step would be substitute y equals 4 into either equation 1 or equation 2. So you look, which one would be easier? Well, it looks like equation 1 will be easier because there's less steps. I don't have to multiply as much, and the numbers look smaller, so let's use that. So x minus my y value is 4 equals -1. That's what it says in the equation. Okay, solving for x, I just have to add 4 to both sides. So if I to balance the equation, so x, so -4 goes away on the left, and then on the right I have -1 plus 4. So -1 plus 4 is positive 3. So there it is, x equals positive 3. So therefore, my point of intersection, or my solution, is x comes first, so 3 comma 4. Okay, and then you check your work. Always check, check, and check. So equation 1, x minus y equals -1. Plug in your values. X is 3 minus 4 equals -1. So -1 equals -1. Left side equals right side. Very good. And you check the second equation. Let's write it down here. So second equation, which is 2x minus y equals 2. So 2 times x, x is 3, so replace it with 3, minus y, which is 4, equals 2. So 2 times 3 is 6, minus 4 equals 2. 6 minus 4 is 2, so 2 equals 2. Left side equals right side. Okay, so we just checked our work. It checks out. The solution is correct. And so, yeah, and the reason why it's correct is because the x and y values satisfy both equations. All right, let's look at one more example. Example number 4. So here I have x plus y equals 5 and 3x minus y equals 7. So I have to isolate one of the variables. I'm going to isolate the x in the first equation because it looks like it's easier to isolate. You can also isolate y too. It's just probably just as easy. So if I do x, here's what I'm going to get. So x, let's call this equation 1, equation 2. So in equation 1, x equals, if I subtract y from both sides, 5 minus y. Okay, and it's all right to have y mixed with other things. You know, I know you're used to seeing linear equations, y equals mx plus b, but get used to the idea that variables can be moved around. It doesn't matter which variable you're moving around, as long as you're doing it correctly. Okay, now I'm going to substitute this equation into equation number 2. So here's equation number 2. 3x, and x is going to be replaced, substituted by 5 minus y. And then I have my minus y equals 7. So now equation number 2 doesn't have any x's anymore. It's just y's. Okay. Expand and simplify. So 3 times 5 is 15. 3 times y is minus 3y. And then you have your minus y outside equals 7. No more brackets. And here we go. Collect like terms. Minus 3y minus y is minus 4y. And if I subtract 15 from both sides, I have 7 minus 15. No more 15 on the left. Okay. And then you divide, let's simplify a little bit. Negative 4y equals 7 minus 15, which is negative 8. And if I divide both sides by negative 4, I can isolate y. So y equals 8 divided by 4 is 2. So there we go. Y equals 2. Now substitute that back into one of your equations. So I'm going to pick the first one. So x plus my y value, which is 2, equals 5 on the right side. So x must be equal to 3, because 3 plus 2 is 5. And so therefore, the solution is 3, 2. Okay, and then again, check your work. Always check, check, check. So if I check the first equation, x plus y equals 5. Well, 3 plus 2 equals 5. There, 5 equals 5. Left side equals right side. Good. Okay, and equation number 2, 3x minus y equals 7. Plug in your x and your y, so 3 times 3 minus 2 equals 7. 3 times 3 is 9, minus 2. And so 9 minus 2 is 7. Left side equals right side. Okay? All right. And so that's how we do substitution.